All right, classifying matter. So we need to understand what matter is. It's going to have mass and volume, so it's going to take up space. And matter can be classified as a substance, and we usually say pure substance or a mixture. And so if it's a substance, all the particles are identical, and the key is it's a fixed composition. If it's a mixture, there's two or more substances that are combined, but their composition isn't fixed. So think about a tossed salad. If I make a tossed salad, the amount of tomatoes I put in it might be different than the amount of tomatoes you put in it. But a water molecule will always have two hydrogens and one oxygen. So it's always a substance because it's a fixed composition. So that's the two things I like to look at for that. So under pure substance or substance, we have elements, and these are going to be found on the periodic table, and all the atoms in that element are going to be alike. So helium would be an element, carbon would be an element, oxygen would be an element. If you find it on the periodic table, it is an element. Um, And then elements, if you look at these diagrams here, are either going to be single circles or they could be two atoms together as long as they are identical. So oxygen will typically exist combined to another oxygen. And so they can be considered still an element because all the atoms are the same. So if you see a picture like either one of these, you would list it as an element. The second one could be considered a compound because it is two things that are joined, but the definition of a compound typically says two different atoms joined together. So that is why this is classified as an element. So be familiar with that picture. A compound is two or more elements chemically combined, and they're in a fixed proportion. So, for example, water is H2O. It can only be H2O, two hydrogens, one oxygen. Salt is always one sodium and one chlorine to make table salt. Sugar is, or one form of sugar is C6H12O6. And so these cannot be broken down except through chemical reactions. So you can't separate it without a chemical reaction. And their properties become different once they have combined with another element. Um, so this is what they would look like on kind of the molecular level. So we said this is an element because they are the same atoms joined together. But here you've got two or more elements chemically combined. So you sometimes you'll see the word differently there, different elements. So here we have carbon dioxide. It has one carbon and two oxygens. So these pictures you'll want to refer back to when you work on the worksheet. In the PowerPoint I'll post. Um, Mixtures, there are two types. We have homogeneous and heterogeneous. Homogeneous are going to look the same throughout. So here are some examples. They look the same. Um, it's when you have a solution is when you have one substance dissolved in another. It's going to appear blended, but it's not chemically combined, so it's not really a new substance. So bleach, lemonade, blood, coffee, these are homogeneous because they look the same throughout. Then you have heterogeneous mixtures. These look different throughout or they settle out over time. So paint, you say, well, that looks the same throughout. Well, if you leave a paint can sitting and then you open it to use it, typically you have to stir it because substances have settled out. So that makes it heterogeneous. You can see the different parts or it settles out. Think about Italian salad dressing. All right, mixtures. So here is homogeneous. Notice we have about the same number of each different type of element or compound. Heterogeneous is uneven. There are different numbers of many different things. So that's sort of the picture of how you can tell those apart on the molecular level. Again, these pictures like this are going to come in handy on the assignment you're going to do. And so there's also a colloid. A colloid is considered heterogeneous, and it's very hard to, you want to sometimes lump them into homogeneous, like milk is the same throughout. But typically with a colloid, um, the you can't shine, it's called the Tyndall effect. Light cannot pass through it. It's very difficult. It may reflect light back. And so, fog, milk, humid or dusty air, these are all colloids because the small particles are suspended throughout it, so it looks even, but they're larger than what they would the particles are actually larger than what they normally would be. Suspensions are the ones where you're going to have things suspended, and a lot of times they will settle out over time. They're not going to be stay mixed. So oil and water, sand and water, your muddy water, those are a type of heterogeneous mixture. The Tyndall effect was what I was talking about with colloids. It's the sort of the scattering of light. So the particles are large enough that the light will kind of bounce off of it and scatter. So the Tyndall effect is with colloids. And so here's a chart. This may help you in filling out the first part of the homework. You may have to add, like, I think there's places for some examples and things like that. So you might want to flip back through in the PowerPoint. Um, hold on. I thought I had more. I guess, hold on. Did I already cut this? Maybe I did. I thought I had more slides than that. All right, so we're going to stop right there. Let me stop